The Atom by us.
Okay, so the first philosopher of the atom was Democritus, and he was in 400 BC, and he was Greek.
And he stated that all matter is made up of atoms, and he also stated that atoms are eternal and indivisible and so small that they can't be divided, and that they entirely fill up the space they're in.
And then there was another guy during the same time period of him in Greece who also thought that of the atom. Or no, he didn't think of the atom, but he had a philosophy. And
He was Aristotle.
And he believed that the four elements, earth, air, fire, and water, could make up any object
or any type of matter.
Yeah, in the earth.
And he was more popular than Democritus in his time because his ideas
stuff made sense.
Yeah, his ideas were like, I don't know, they were more popular.
They could understand it.
Yeah. But Democritus was more correct. And then the next philosopher guy was present in the 1800s, like AD, and his name was John Dalton.
And he formed the atomic theory, which states that all matter is composed of tiny indestructible particles called atoms that are all alike and have the same atomic weight. And he also just thought of the idea, well, not the idea of the atom, but more in depth about the atom.
And he also discovered what we now know to be how compounds are formed, and he discovered that you can separate a compound into its original elements and by chemical means.
Also, some of his thoughts were that atoms are always moving, which was very extreme for his time.
Yeah, very advanced.
You can't just stare at something and say, "Oh, that's moving."
Yeah.
Next, we have J.J. Thomson. He was in the 1800s as well.
The late 1800s.
Yes. And he
discovered the electron and developed the plum pudding model of the atom. And his experiment used a cathode ray, and that was that glass tube with the
light beam in it.
Yeah, and the charged plates on either side that attracted the electrons that he got in the ray.
Because the ray was negatively charged.
Yeah, and so then the positively charged thing attracted it, and he saw where it landed on the end of the glass. So
yeah, so basically the negative went to the positive.
Mm-hmm.
And his plum pudding model was that the atom was, or the electron, was negative, and there were a bunch of them, and it was just in a positiveness-ishness.
Mm-hmm.
Yeah.
Okay.
Rutherford.
Ernest Rutherford was discovering things about the atom in the early 1900s. And
he used the gold foil experiment to state that all the mass of an atom were in small positively charged ball at the center of the atom,
called the nucleus.
Yes, and the gold foil experiment was that they had a little light beam which was positively charged.
Mm-hmm. And then it came from that stuff, the radioactive decay from radon, and then it shot the
gold foil.
Yeah, it shot the decay at the gold foil, and then he thought it would all go straight through, because he thought atoms were mostly empty space, so they would go straight through. But some of the particles, the nucleus, hit the gold foil nucleus stuff.
Anyway,
the light stuff, the beam hit the nucleus of the gold foil, and some of it bounced right back, and some of it got like deflected and stuff. So that's how he discovered it.
And there's a circle of zinc.
It was something like circle.
Zinc.
Yeah.
Around it, and it would light up whenever something hit it, so you would know where it hit.
Yeah, and he knew where the stuff hit. So that was Rutherford or whatever. Oh. The next guy was Niels Bohr.
And he was in the early 1900s too. And he stated that the electrons move around the nucleus in successfully large orbits. He also presented the Bohr atomic model, which stated that atoms absorb or emit radiation only when the electrons abruptly jump between allowed or stationary states, like the ladder.
Yeah, the levels of the electron paths.
And he he thought of the one with all the lines.
Yeah, like the Jimmy Neutron model.
Yes.
Mm-hmm. Okay.
Next is Erwin Schrödinger.
Schrödinger. Yeah, and he was popular around 1926.
He introduced the Schrödinger equation, a wave equation that describes the form of motion of the probability of waves that govern the motion of small particles and how these waves are altered by external influences, the electron cloud.
The probability regions of where an electron might be around the nucleus.
Yeah. And that is it.
Thank you.
Woo.
P.S. There were also Chinese alchemists and European alchemists, and the Chinese alchemists searched for eternal life, and they combined mercury and sulfur to make cinnabar, and that was not good because once you ate that, you died. And also the European alchemists, they wanted like a lot of money and stuff. So they tried to turn lead into gold, which is not smart because lead's not very reactive. So they did not succeed. Okay, thank you. That's it.